So we're talking about your syllabus. Calculus is really made of three main topics: limits, derivatives, and integrals. Welcome to integrals. What the crap is an integral? Oh, well, I know you don't know. So why are you here?
Learn.
Good. Okay. I give you the equation 2x equals 8. Now, when that was a hard question for you to do, back way long time ago in your life, what did you do to both sides of that equation to solve for x? Why did you choose division? Opposite? Inverse. It's the inverse of multiplication. So to undo multiplication, you divide because they're inverses. They undo each other. To undo addition, you subtract. Addition and subtraction are inverses. We are. They're integrals. The inverse, essentially, of a derivative is an integral. How do you undo a derivative? You do an integral. So in the same way that derivative relates to that word differentiation, integral and integration. Okay? So you are going to start learning all about integration. Now, question. I haven't passed those out yet. So we're good there. Oh, so if you want to undo a derivative, you integrate. So you know how with a derivative, if you knew f, you could find f prime, right? But with an integral, guess what? If you know f prime, you can find f. Aha. Indeed. Now here's what I want you to do. I want you to have a partner. Let me see how we're doing on partners. Now here's what you're going to do. The first thing is whose next birthday is closer to today? Whose next birthday is closer to today? So hers just passed, yeah. Now, the person whose birthday is closer to today is going to be the explainer. The other person is going to be the learner. And what you're going to do, explainer, you are going to pretend that this learner does not know how to take a derivative of a polynomial. So, I'm going to give you a function. And you are going to teach, getting the bags out already. Where are the Gardettos? All right. So what you are going to do is you are going to explain to your partner how to take the derivative of x cubed. Go.
So you see.
Now, I want the learner to repeat back what they just learned. And the explainer will make sure it's correct, that they learned what they were supposed to learn. To the teacher, to the explainer, did your learner learn what they were supposed to learn?
Yes.
Now, I'm going to give you another function to take the derivative of, and the learner is going to do it based on what they think they learned. You're going to take the derivative of that function based on what you learned, not on what you already know truly, but based on what your teacher just taught you. Now, did your learner learn what they were supposed to learn?
Oh, yeah.
Now, learners are only allowed to speak right now. What is the first thing you do when you take the derivative of a polynomial type function? Learners only. Yeah. Multiply the leading coefficient by the exponent. Write this down. You don't, I haven't given them notes yet. Just a minute. Multiply the coefficient by the exponent. Learners, what did you do after that? Diminished. Ooh, can I just use a simpler word, like
Yes.
lowered, subtracted, lowered, squandered,
Great. Vocabulary, Evan.
lowered the exponent. You should take the SAT. Lowered the exponent by 1. And that is how you take the derivative of a polynomial type function. This is each term for each individual term, correct? Now, what if we wanted to undo this process? How would we undo this process?
Add one first. Add one.
You taught well. She's got this. All right. Which one do you undo first? You got to undo in reverse order, don't you? Daggum. So we're going to do what first? Add 1 to the exponent. And then divide what? Divide the coefficient by what? Which one, the old exponent or the new exponent? The refurbished exponent. Well then, but I'll say new, but we'll put refurbished. Refurbished exponent. Just like we could go back here and say diminished. You're welcome. So see, you guys ought to take the SAT because the SAT is stuff. Big words. Right.
That is good typically it's males.
It is typically the males.
That's what you just
Now, all right. So if I give you the derivative, what was the function that came from based on the rules we just wrote down? F of x. What did you say to do? Tell me what you said to do. I erased it. The first thing you said to do was add 1 to the exponent. And then divide the coefficient by the new exponent. So 2 divided by 6 is 1/3. Ladies and gentlemen, is this the derivative of this for real? You dang right it is. For real. This is what we call the antiderivative of this. Integral, antiderivative, aka integral. Okay? Now, here we go. Whoops. Now I have a question to ask you though. I'm going to give you a derivative. Easy one. What was f of x? Use your rules, the rules you just told me. Raise the exponent by 1, divide the coefficient by the new exponent. Is 3x squared the derivative of x cubed? Yes. Now, I need you to think about this. Is x cubed the only function that has a derivative of 3x squared? I'm going to say that again. Is x cubed the only function in the world that has a derivative of 3x squared? If you say no, you got to give me an example. Does that also have a derivative of 3x squared? Indeed. What else? Plus 8. Indeed. There are an infinite number of equations that have 3x squared as the derivative. But what has to sit right here? A constant. That is a raise the roof moment. You just do not understand. But that is a raise the roof moment. So, I don't know how to write down every constant in the world. So I write down, I don't write down etc. I write plus C. Yeah, no, it's not some earth-shattering thing. Plus C. You can't write down every constant. You'd be here forever. So we write down plus C. Oh, smart aleck. Now, here's what we're going to do. Notice this says find each of the following antiderivatives. And you have that funky symbol. That symbol, when you draw it, looks like that. And when you read that, you read it as the integral of. The integral of. So, if we go back to this problem right here, this one, if I was wanting to find the original equation, the original f of x, I would have written this. I would have written the integral of 3x squared dx. Now, this is what I'm trying to find the antiderivative of. Antiderivative and integral at this point, they mean the same thing. This just says with respect to x. Do you remember when we wrote notation like this? That says the derivative with respect to x of x cubed. This means with respect to x. This means with respect to x. So don't let that bug you. All this means is I want to find what function has this derivative, has this as its derivative, and x is the variable I'm using. Okay, let's go back to that symbol for a second. Do you remember from Algebra 2, do you remember seeing this? Sigma, and it means a summation. You will see soon, this can be interpreted as a summation. So what this symbol is S for sum just stretched. So it's called an integral. I don't have any idea. How do the names relate? Oh, you wait. You're not going to learn that today. You will learn it next time. Just wait. So anticipation, right? Okay. Now, we're going to take the integral or the antiderivative of this polynomial, 3x squared plus 2x plus 3 dx. Ignore the dx. It just means I'm doing it with respect to x. X is going to be in my answers. How many terms do you see in that polynomial? You got 3. So we're going to do the rules we just developed for each of those 3 terms. Okay? What's the integral of 3x squared? X cubed. What's the integral or the antiderivative of 2x? X squared. What's the antiderivative or integral of 3? 3x plus, ladies and gentlemen, you just did your first integral. You don't like this. Did you say I don't like this? Get out. I'm a teacher and a mother. I hear things. Okay. Now I want you to look at the second one. Okay, there came the second bag of Gardettos. All right. That right there, is that a polynomial type function? No, it's rational. It's a rational function because it's got a variable in the denominator. But guess what? You know enough to rewrite this like a polynomial. I don't think reverse hidey-ho is a thing that happens. I don't think that's a thing. Do you remember? What's that?
4/6 plus 1.
It's 5/6, right? What's this? That's also 5/6. When you have a single term in the denominator and multiple terms in the numerator, you can split them up. Ladies and gentlemen, when you see something like this right here, that's what I expect you to do. How many fractions will we split that up into? 3. So let's split. This is going to be the integral of x cubed over x. What's that? What's x cubed over x? X squared. Plus 2x over x. No, I am simplifying this. Here's what I'm doing. I'm taking every one of those terms, that's a minus, and dividing them by x. So I'm doing a rewrite. What's my second term? Now, what's my third term? Do you notice that that trinomial is in parentheses? If you have more than one term, you put the polynomial in parentheses. All right, let's do it. I can rewrite that as 4x to the negative 1. Yep. Okay. What's the antiderivative of x squared? Think through your rules. You're probably lost as a goose, aren't you? Yeah. 1/3 x to the third. Remember, raise the exponent by 1. Raise the exponent by 1 and divide the coefficient by that new exponent. So 1 divided by 3. So let me try to give Gisela a little heads up. Gisela, what we're doing is we're going backwards. Okay? So if I have x squared, if that's my derivative, and I want to go back and figure out what the function was, I raise the exponent by 1, and I take the coefficient, which in this case was 1, and divide it by that new exponent. Now the issue is that the only equation in the world that has a derivative of x squared? No, because if I added 1, the derivative of 1 is 0. So this would have the same derivative. So what we do, any constant could be there. So when we finish this, we put a plus c on the end to indicate there could be a constant. So that'll get you a little bit going. Okay. So right here, what'd you say for 2? 2x minus. Why? Undefined? Oh, because you can't divide by 0, because that would be x to the 0, right? And then 4 divided by 0. Hmm. 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 What if, what if I asked you to do that problem? There is a function out there that has a derivative of 1 over x. The natural log.
Of course.
The natural log. Yeah. Natural log. Ladies and gentlemen, respectfully, I don't like that. Respectfully, too bad. Okay, so in our case, we had a 4 there. Now, does the 4 go here, or does the 4 go here? Because if we took the derivative of this one, I'd have 1 over 4x times 4, which would be 4 over 4x, which would be 1 over x, which is not 4 over x. So the 4 is going to go in front as a coefficient. Anytime you have an x to the negative 1 or something over x, your antiderivative is natural log. So this was 4 over x, right? So it's minus 4 natural log x plus c. I love doing intervals. Lower left corner. What do you think about that one in the lower left corner? How could we take the antiderivative of that?
You multiply them together first?
You betcha. Let's multiply them together first. We're just going to do a rewrite. Integral or antiderivative of the Please tell me you're getting that when you multiply. Yes? Integrate or take the antiderivative. What's the antiderivative of 2x squared? Yep. Yep. 2/3 x cubed plus x to the second 1/2 x squared. Yep. Minus 6x plus c. Plus c. You have questions so far? You're doing good. Lower right corner. That is not a polynomial. I can make it kind of look like one, though. By doing what? 2x to the negative 1/2. So we're going to do a rewrite. 2x to the negative 1/2 dx. Let's leave it as fractions for right now. How'd you get x to the 1/2? Perfect. Okay, so we raised this exponent by 1, so that's going to be x to the 1/2. And then what'd you do? What's 2 divided by 1/2? That's 4, yep. Let's see. Do you have to write this as 4 square root x? No. You can leave it here. If you want to write it as 4 square root x, that's fine. Do you have questions so far? Next page. You knew Trig had to come in here somewhere, right? Woohoo! You knew Trig had to come in here somewhere. Your brain hurts. Well, then I've done my job. All right. Look right here. You know that. You know the derivative of sine x is cosine x. And you know the derivative of cosine x is minus sine x. So can we go backwards? What is the antiderivative of cosine x dx? Now remember, what does that mean? It means what function has a derivative of cosine x? Sine x. Plus c. What function has a derivative of sine x? There you go, negative cosine x plus c. You're doing great. All right, so let's do a few with a trig function. I just remembered there's something I wanted to tell you back over here and I forgot. Go back to that last problem we did. Here in the lower right corner. You've got this down as your answer, correct? You notice that that 2 is a coefficient. What if I did this? 2 times the integral of, pretend that dot's not there, of x to the negative 1/2 dx. And that would be 2 times, what's the integral or antiderivative of x to the negative 1/2? It's x to the 1/2. And you're dividing the coefficient by that new exponent, so it's 1/2 divided, 1 divided by 1/2, 2 plus c. Okay? So in a single term, if you have a coefficient, you can bring it out and multiply by it later. Sometimes that's easier, sometimes not. All right, let's go back to sine and cosine. How many terms do we have in that upper left integral? 2 terms, so we're going to integrate twice. What do you think? Where are you getting a square? Now that 2 is a coefficient. Okay, so you could think of it like this, 2 times the integral of sine x dx. So we could think about it that way. What function has a derivative of sine x? Negative cosine x. So it's 2 times negative cosine x. Does that make sense? You don't, notice up here, notice that we didn't change the exponents, okay? Now let's finish it. What function has a derivative of positive cosine x? Sine x. Let's see. That's it. Remember, you take the derivative of this, make sure you get this. That's how you can check it. Bless you. Bless you. All right. Now this next one combines polynomial with sine cosine. What's the antiderivative or integral? T squared? What function has a derivative of minus sine t? Is it, okay, so it's cosine. Is it plus or minus right here? You sure it's plus? Because what's the derivative of cosine t? Plus? Plus c. about the third one? Come on, work it. 2x squared. Now remember, you can pull that out as a coefficient, so you can think it like this. We're going to check it. What else do we need? Remember, you check it by taking the derivative of this and making sure you got this. What's the derivative of 2x squared? 4x. What's the derivative of negative 3 sine x? Negative 3 cosine x. That's what you got here. You're good. Here. Rewrite, please. Integral of x to the, oops, got ahead of myself. Carson's got it. Raise that by 1. 1 divided by 3/2 is 2/3. You sure it's minus cosine? The derivative of minus cosine is positive sine plus your constant. Just be careful on your signs, plus and minus, when you do sine and cosine. Now, yesterday's class, the 8A class asks a lot more questions than you guys do. Why don't you take a look at this one? We are told that f double prime of x is 2. We are told that f prime of 2 is 5. And we are told that f of 2 is 10. I can use that information to figure out what f of x is. Now I want you to think about something. When I integrate f prime of x, what do I get as my answer? I get f of x. All right. What do I get when I integrate f double prime of x? I get f prime of x, right? Oh, so if I know the acceleration and I integrate acceleration, what do I get? Velocity. And if I integrate velocity, I get position. Oh. So, we're working backwards trying to find f of x. So what we're going to do is we're going to integrate f double prime of x. Now you don't have to write this piece down, because that's going to give us what? F prime of x. So here's what I want you to write down. F prime of x equals the integral of, what is f double prime of x? It's 2 dx. Don't forget that dx. I will take off points if you forget that dx. Oh, do you have a question? How do you integrate 2? What's the antiderivative of 2? 2x plus a constant. Bye. Now, if I'm going to integrate f prime of x to find f of x, I can't integrate c, so I got to figure out what c is. Look what I know. So let's, so f prime of 2 is 2 times 2 plus c, but I know that has to equal 5. C is 1. So now I know what f prime of x is. Exactly. It's 2x plus 1. Are you all at an okay place? Are y'all thinking? Okay. How far? So, I'm still wanting to find f of x. I know f prime of x. How do I find f of x?
Integrate that again.
I'm going to integrate f prime of x. So f of x is going to be the integral of f prime of x. So let's integrate. What is the integral of 2x plus 1? Good. Good. X squared plus x plus c. Now, remember, you cannot just automatically say c is 1 because this is what you are told about f of x. You are told that f of 2 is equal to 10. So if f of 2 is equal to 10, so f of x is x squared plus x plus 4. Question?
I did figure that with it. Why couldn't we go straight to like f of x equals
The integral?
yeah.
It doesn't work that way. You can't.
Because the double.
Because,
That's just a double.
yeah. Okay, we're having a question here, so I'm going to turn it off. Thank you. Okay, so Catherine, you have a question about. Shh. Number 2. Same idea. We are given f double prime. We are given. Now, listen. What that's called is an initial condition. Don't worry about it right now. That's just what it's called. That too. We're told some specific point. Okay. Well, it's not. That was not an initial condition, so I take that back. But we are given a point. How do I find f prime? F prime of x is the integral of the second derivative. So the integral of the second derivative with respect to x what is f prime of x? What is the antiderivative of x to the negative 3/2? Say again? X to the negative 1/2 the original coefficient divided by negative 2. Remember, it's the original coefficient divided by the new exponent. So 1 divided by negative 1/2 would be negative 2. All right, we are told f prime of 4. So that'll be, can we be happy doing this? Is that true? Please tell me that's true. Negative 2x to the negative 1/2 is the same, is the same as negative 2 over the square root of x. Okay, so what does that give you? Negative 1, right? Negative 1 plus c. So c is 3. You okay there? So I know c is 3. So f prime of x is negative 2x to the negative 1/2 plus 3. How do I find f of x? Again, integrate again. So f of x is the integral of negative 2x to the negative 1/2 plus 3 dx. Notice that that binomial has to go in parentheses. Whoops, that's supposed to be f of x.
So if it's more than one term, it has to be in parentheses?
Yep, if it's more than one term, you got to have it in parentheses. All right, let's go. X to the 1/2. What are we going to divide that coefficient by? 1/2. Negative 2 divided by 1/2 is negative 4. Good. Keep going.
Plus 3x.
Good. That's f of x. Now I'm given a condition. My condition was that f of 0 equals 0. If f of 0 equals 0, what is c? C is 0. So f of x is negative 4x to the 1/2 plus 3x.
That one on the AP example, we have to like write out.
Write out substituting in.
Just write that.
You mean write out that you plugged in 0? No. Nah, they would expect you to be able to do that in your head. Questions on this page? I do believe we have one more page. And I don't think there's anything on the back. Is there? No. Okay. We will be able to finish. Good. All right. If any of you are going to study engineering, and I think a few of you are, if you go to the U of A, you will take what's called the calculus sequence. That's Cal 1, which you're in now, so you'll be done with that. Cal 2, Cal 3, Diff E. Now, Diff E is short for differential equations. Now, I don't want you to freak out about differential equations because you see the term differential equation right here. A differential equation just means this is an equation that is the derivative of something. It's like saying this is f prime of x. So a differential equation just means that's the derivative of something. My Diff E teacher at the U of A was horrible. He was the one, if I've told you this, just say, oh, well, she's getting old and doesn't remember. He's the one who, he gave 0s, 1s, and 2s for homework. And I went and asked him one day, I said, how do you grade homework? I need to understand. And this has been more than 30 years ago, but I remember it like it was yesterday. He said, oh, not worry, not worry. And that's what he did with his hands. He was Japanese, not an issue, but that's what he said, oh, not worry, not worry. Well, I worried. I made an A, but I worried a lot. So anyway, he was my Diff E professor. He was a quite older gentleman, and had him in the science engineering building. And any time that you heard this coming down the hallway, you knew it was Dr. Kimura or Dr. Sakaguchi because they wore their slippers when they were not teaching, and they scooted. And you're going to have all kinds of stories to tell about professors after you're in college. I'm just going to tell you. Well, Dr. Kimura, you always knew Dr. Kimura. Dr. Kimura looked like he took a hair dryer when he washed his hair and held it right at the crown of his head because all his hair went like this. So you will have stories about your professors, and you'll remember them. I'm just going to say he wasn't a very good teacher. But anyway, I made an A. Okay. So let's take a look. An evergreen nursery usually sells a certain shrub after 6 years of growth and shaping. The growth rate, you know that's a derivative because it's a rate, during those 6 years is approximated by that differential equation, where T is the time in years and h is the height in centimeters. The seedlings are 12 centimeters tall when they are planted at time 0. Now, the first thing I need you to think about is how are your points set up? Meaning, what are the two amounts, the two quantities that you are dealing with in this problem? Time and height. Which one's x? Time. So it's t and then h. Now, when you see, come on, work with me. There's a highlighter. When you see something like this, I want you to immediately, I want you to stop and write 0, 12. Find the value of the differential equation above when t is 3. I'm trying to find the value of the differential equation, so I'm trying to find the value of this when t is 3. Notation, how do you write it? You write dh dt at t equal 3. Write it like that, big long bar. 1.5 times 3 plus 5. What do you get? 9.5. Using correct units of measure, explain what this value represents in the context of the problem. What are our units of measure? It's a rate. Centimeters per year, right? Centimeters per year. What does this number, 9.5 centimeters a year, mean in the context of this problem? Three years after planting. That's right. 3 years after planting, the shrubs are growing at a rate of 9.5 centimeters a year. Do you understand that? 3 years after planting, the shrubs are growing at a rate of 9.5 centimeters per year. You can get this off the notes when I post them if you want to. I'm not going to take the time to write that down. Find an equation for h of t. I know how to do that now. I'm given dh dt. How do I find an equation for h of t? Integrate. H of t is going to be the integral of 1.5t plus 5 dt. Why did I not put dx? Because my dang variable's t. It might be in your best interest to change 1.5 to a fraction as you think through it. T to the second. 3/2 divided by 2 is the same as 3/2 times 1/2. 3/4. Yeah. 3/4 t squared plus 5t plus c. Aha. Now we're going to go back and use that point because we got to figure out what c is. Well, we were told that the seedlings were 12 centimeters tall at planting time t equals 0. So h of 0 is 12, right? What's C? C is 12. Good. So my h of t is 3/4 t squared plus 5t plus 12. We got the equation. Woohoo! Do you have questions so far? Theron, is it getting better? Determine how tall the shrubs are when they're sold. How old are they when they're sold? 6 years. So what do I need to find? H of 6. Yep. Sorry, my stomach's growling. Hmm? 69? So what sentence would we write? The trees or the shrubs are 69 centimeters tall when they are sold. Mm-hmm.
Wait, do we have to write that?
Yeah. What did it ask? Well, I still will prefer, for me, a sentence. Now, on the AP exam, it would be fine if you put, whatever, 60, what does it say, 69? 69 centimeters at 6 years. It'll accept that. But I want sentences. All right, we are almost done, guys. Almost done. A particle moves along the x-axis at a velocity of v of t equal 1 over root t, for t is positive. That makes sense. Can't have a negative time. Now look at this one. At t equal 1, the position is 4. Now, be careful. That's position. That's not velocity. Okay? So, what variable does he typically use for position? So, let's do this. Position at time 1 is 4. I don't want you to just automatically say 1/4 because I don't want you to assume that that means 1/4 is in the velocity, because it's not. It's a position. I'm sorry, my stomach is... No, it's not good. Okay. What's the acceleration of the particle at 9 seconds? I don't know if it's 9 seconds, but at 9. You're given velocity, you want to know acceleration. Take the derivative. Be careful. Don't think, shoot, I'm in the integral section, so I'm going to take the integral. Not necessarily. You're finding the acceleration. Do you need to do a rewrite on velocity to take the derivative? I do. What is it? Yep. So a of t, which is v prime of t. Yeah. What's the derivative? Mm-hmm. Mm-hmm. Uh-huh. Yeah. I got to evaluate that at 9. So I'm going to do a rewrite because that I just can't do that. I can do that better. Yes? Can you do that better? So a of 9. Negative 1 over 2 times 9 to the 2/3 or 3/2, whatever the crap that says. Can you do 9 to the 3/2? I could do 9 cubed, but I can't do that in my head. And then take the square root of that. Or I could do square root first and then cube. I can do either way, whichever works better in my head. Square root of 9, 3 cubed. 27 times 2. There you go. Remember, on a free response, that's a safe stop. For real.
Wait, but not.
Why did I get 54? Oh, I did it. I went ahead and did the multiplication out, didn't I? Square root of 3 is crap. The square root of 9 is 3. 3 cubed is 27. That's a safe stop. I think they would consider that a safe stop. Yep.
What if I just plugged in the 9 to the original negative 1/2 t to the negative 3/2?
If you plugged in a 9 right there, I think so. Yeah, I think that's a safe stop. Position. They don't give me any units, so you don't have to put units or units square. You don't have to do that. What's the position? How do I find the position of the particle? Integrate the what? The velocity. Good. So position is the integral of the velocity t to the 1 divided by 1/2. But remember, we had that condition, P of 1 is 4. What's C? C is 2. Are you good with C equaling 2? So P of T is, and you can write 2 root T or you can write 2T to the 1/2. It does not matter at all. Oh, we got to do a when? Well, snap. When T is 9. All right. What's P of 9? Why did I write a 3? It's Friday. Man. What's that? 6 plus 2? 8. You learned a lot today.
Time for the weekend.
Now, what did you just say?
It's time for the weekend.
It is. And you have a little homework to do.